today, section 5.2, what are called inverse functions. Basically, I took chapter 5 and I really kind of ripped it apart. We did section 1 before. We're doing section 2 today because once I cover inverse functions, I'm ready for chapter 6. And in my mind, chapter 6 is one of the most important sections of the course in terms of new functions. Most important section, probably 1.7, transformation. The most important chapter is chapter 6. Because that's new to you guys, and it also has so many applications, I think. I think it'll be new to you. We'll see. But anyways, inverse functions are very important if we want to talk about that chapter. And so I actually gave you an example already of some inverse functions on the board today. We wrote down f of x is 4x plus 3. We wrote down g of x is x minus 3 divided by 4. Okay? And I asked you guys to compute a couple of things for me. I asked you to compute f composed with g of x. And of course we said that means f of g of x, right? And so what I'm going to do is I'm going to write down f of x, but I'm going to put a parenthesis where the x used to be, and where it used to say x, what am I going to write? We need to put this g of x in where the x used to be. Does that make sense to people? Okay, so I write down x minus 3 over 4. Well, what I'm hoping you did then is you simplified. Did you simplify? What'd you do? The 4's cancel. So now I'm at x minus 3 plus 3. And so what I get is I get that f composed with g of x equals what? X. That's kind of a nice answer. Okay? Now, then I had you guys try g composed with f of x. All right? So let's see what happens. Well, how'd you guys do this? Well, same way, right? We go g of f of x. Right? So this time I'm going to write down g, but where it used to say x, we're going to put something else. So I'll have something minus 3 divided by 4. Does that make sense? What other way? Yeah, I think so. We'll see that in a minute. I'll show you what I do, and then we'll try your way and we compare. So let's see. F of x is what? So I put the 4x plus 3 here, right? And so now, if I were going to simplify, I guess my next step is I'd take the parentheses away. They don't need to be there. And then what happens? Well, those 3's are gone, so I get 4x over 4. And so I get that g composed with f of x is what? So Barbara, did you get x? Did you do it differently? How many people did this one differently? 1, 2, 2. All right. We'll take a look at it, okay? So I want to go ahead and sketch a graph of each of these. So let me draw some axes. So if I want to graph the green function, f of x, where should I start? Where? 0, comma what? What's f of 0? Yep, and what's the intercept? 3, right? So there's the intercept, 0, comma 3. And what's the slope? Sure, so I'm going to go up 4 and over 1. I'll be off the page. or I go down 4 and over 1. But basically, the graph I want looks like this. It follows those dots. Thank goodness Lakeland gave me an ID card. And so now, not only can I get in the AFC, but I can do my math homework. There we go. All right. So there is f of x. Question, Matt. What's that?
What function do you use to graph that?
This one here is just f of x is 4x plus 3. So again, I used the fact that the y-intercept was 3, and I have a slope of 4. So if I go up 4 and over 1, I'd be here. Or down 4 and back 1, I'd be there. Okay? We also want to graph g of x, guys. I said we should rewrite it. Were you guys able to do that? How would you rewrite g of x if you want to graph it? Augusto? Okay. Or the way Amanda was saying it was 1/4 x. You could say x over 4. You could say 1/4 x. It's the same thing. And then minus what? 3 over 4. Cameron, you got a question? I mean, the y-intercept for this g of x would be right here about, but it's hard to plot points that are fractions like -3/4. So maybe what you do is you plug in some other number and you get a nice, Well, for example, if I put in x equals 3, what do I get for g of x? Do you see that? If I plug in x equals 3, what's g of 3? Yeah. G of 3 is 0. And now I can use the slope. My slope is what? Well, 1/4. Right? So I can go up 1 over 4. Or I could go down 1 and back 4. I could see where they intersect right there. Okay? So if I were to graph g of x, it looks like this. Something like that. So f of x is in the green, g of x is in the pink here. Okay. And I asked you guys to graph one more function for me, and that was I wanted you to graph y equals x. Now, what does y equals x look like? What's that? A slant, right? It goes right up the 45-degree angle, right through the origin, right through that point. Actually, it goes right through that point where they intersect. Okay? Now, do you see why I had you graph y equals x? Mario? Yeah. Not only is it like a middle, it's almost like a mirror. Right? You have symmetry. Symmetry is huge in mathematics. If you want to understand mathematics, that's something to look for. Do you guys see what I mean by a mirror? If you were to graph these two functions and you think of that as a mirror, the green and the pink really are reflections of each other across that line. Okay? Now I told you that the green and the pink here are examples of what are called inverse functions. Let me give you a definition. Or maybe you saw the definition if you were preparing for today. We say f of x and g of x are inverse functions if, and you need two things to be true, f composed with g of x has to be x. both of these. You need f composed with g of x to be x, and you need g composed with f of x to be x. You need both. And if we have that, then we call them inverse functions. Okay? So this is our first example. And now, I guess the question is, what do I mean by inverse functions? Well, it's like this. If you have a picture of some, this is my domain. What's that mean? Well, range is the opposite, right? Over here, maybe I'll have the range. Okay? But what happens is, let's see if this makes sense to you. If I pick some x, and I apply the map f, well, over here, I'll have something called f of x. Does that make sense? And then what I want to have happen is, if I take f of x and apply g to it, I want g of f of x to be what? X. I want to be able to undo what I just did. That's the idea of inverse functions. When I put it that way, you could probably come up with an inverse function pretty easily for some functions. Okay? Let's suppose I have f of x equals 7x. Can you tell me what you think g of x should be so that you'll undo the action of f of x? Well, that's easy, right? It's some people have said x over 7, right? Or 1/7 x. That's easy. Multiplying by 7, when we want to undo it, what do? We divide by 7. By the way, it's actually worth it to sketch the graph of those two functions. Rather than use the graph paper, I'm going to show you what it looks like on the graphing calculator. So if I type in y equals 7x, and then here I'm going to type x divided by 7, we said those are inverse functions, right? I want to show you something that might help. You guys, usually we've been hitting choice 6 here, zoom standard. And when I do, well, it graphs the two lines. I don't know, can you tell? I guess there's one more thing maybe I should plot, and what would that be? Let's plot y equals x, okay? Y equals x. But I want to show you one more thing you can do on this calculator. One thing I can do is the different zooms, I can hit zoom square. And what this does is it makes all of the tick marks the same width apart, so it looks more like your graph paper. This is what zoom square would look like. And by the way, can you see the reflection going on? Yeah. See, if I hit zoom standard, choice 6, it might not really look like a perfect reflection. And the reason is because these tick marks are farther apart than those tick marks, because it's a rectangle screen. So a lot of times when you're doing this, you may want to do zoom square when you're working on the homework tonight. Okay? And you can check very quickly here that f of g of x equals what? G of f of x, they both equal x, okay? So that's pretty key. Where would the horizontal asymptote be, guys? 4/3, right? So at y equals 4/3, we have a horizontal asymptote. Wow, okay. And anything else I could say about this function? Well, if I plug in 0, I'm at negative a third. That's somewhere around here. And if I plug in something like 3, I'm at 14/5, which is almost 3. It's up there. So without doing too much detail, I'll tell you the graph looks approximately like that. Okay? We didn't do a sign diagram. We could do that. I just want to kind of move on because the goal here was not to graph it. The goal is I want to do what? Find the inverse. Okay? Now, that's tough. Well, I don't know. The thing I can say graphically is this. When I graph the inverse, it's going to be a reflection if I also have what graphed? Let's try to sketch in y equals x. So here's 1, 1, 2, 2, 3, 3, 4, 4. Okay? This is challenging. To say that I'm going to need a mirror image of this black function here across that green line, it actually isn't going to look too much different, I don't think. I mean, I'm picturing these things as like, I don't know, black licorice that I flip-flop around the axis. That's hard to do. All right? This is kind of cool. To find the inverse, we switch the input and output. That's what we do. We switch the input and output. And the reason I do that is because, which letter is the input here? X, right? And the output is y, let's say, although I know we've been calling it f of x for this one. But if I switch x and y, what I'm doing, guys, is this. I'm taking the axes. There's the blue and the green. If I switch the input and output, I'm doing that reflection across the line y equals x. Maybe you could see that. If not, let's at least try it now. Okay, so how am I going to accomplish switching the input and output for a function like this? Well, it's a little challenging. So I'll start off by rewriting the function this way. Y equals 4x plus 2 over 3x minus 6. Okay? Next, we switch input and output. And if I do that, what letters am I switching? X and Y, right? So let's see what I get. I get X equals 4y plus 2 over 3y minus 6. And now what I really want to do is I want to solve for y. Barb says, let's multiply both sides, okay, by 3y minus 6. So I have x times 3y minus 6 would equal 4y plus 2. I just cleared out the denominators. Does this make sense, people? So now what can I do? Your algebra instincts tell you to do what? Distribute? I hope so. So 3xy minus 6x is equal to 4y plus 2. Why not? Here, let me show you one more step, and then you'll know why I distributed. Okay? See, here's the problem, guys. Over here, I had how many y's? 2. Eventually, I'd like to only have one output, y. And so the next step I'm going to do is I'm going to put everything that doesn't have a y on the right-hand side. So in other words, not only am I going to have the 2 over here, but I'm also going to have the plus 6x over here. Do you see what I mean? It used to say minus 6x, but what I did was I added it to both sides. Are you with me? And then I'm going to say that that equals 3xy, and you know what else I want to do? I'd like to bring this y over there. So what am I going to do to both sides? Subtract 4y. And so I'll have 3xy minus 4y is equal to 2 plus 6x. Why the heck did I do that? Well, there's a trick I'm going to do now. I'm going to undistribute, or factor. What's the common factor on the left-hand side? So if we take out the y, now I have 3x minus 4 in the parentheses, and all this equals 2 plus 6x. Okay. Then we can divide, right? And so we could solve for y. We could say, well, y equals, and why don't I write 2 plus 6x over 3x minus 4. Okay? And that's y. But we actually have a notation for the inverse. You know how last time I put g of x? You can actually write f negative 1 of x. And I probably should have said that on the definition. Okay? F negative 1 of x would be this function. Why don't we write it as 6x plus 2 over 3x minus 4. Okay? So that's the inverse function. 6x plus 2 over 3x minus 4. How would I check to see that that's the inverse? What's that? We could graph it, right? We could graph it. Now, graphing takes a long time. I mean, I guess on the calculator it's not so bad. Remember I had this graph? Here, let me do this. Suppose I want to graph 6x plus 2 over 3x minus 4. I don't want to graph very much of it, guys. I really don't. But I'm going to do one thing for you. I'm going to graph the asymptotes. So we're saying f negative 1 of x is 6x plus 2 over 3x minus 4. Where would the vertical asymptote be? You guys can't see that. Where would the vertical asymptote be for this graph? 6x plus 2 over 3x minus 4. Wouldn't it be 4/3, right? So where's that? That's around, there's 1. Right around here, at x equals 4/3, you'd have a vertical asymptote. And what about the horizontal asymptote? Where would that be at? At 2, right? So right here at y equals 2. And I'm just going to point out one thing. I'm not going to do the whole graph. But I'm going to point out that you guys see right here is where the intersections, the asymptotes intersect. And you see in the original problem right here is where the asymptotes intersect. And I'm happy about one thing, and what's that? You see the mirror? That's a good sign. Okay? How else could you check if you weren't going to do graphing? Yes, Delaney. Right. We want to do f of g of x, right? And so what the heck would that be? It would be 4 times something plus 2 over 3 times something plus 6. And the something I'd have to put in Well, it's over there. It's 6x plus 2 over 3x minus 4. 6x plus 2 over 3x minus 4. And let me just say, for the sake of time, you do a whole lot of work. And if you're lucky, what's it equal? X. By the way, would that prove it's an inverse? Then you also, for kicks and giggles, you do g of f of x, and you have to show that that equals what? X. That's how you check. So I guess on a take-home test, you never get one wrong because you check it. You have to have enough time. Guys follow? That's a good question. Do we have to check it? What do you mean? I don't know, guys. I mean, if I'm looking at the graph, can I tell if it's an exact reflection across the line y equals x? Not really. There are times where you need to do this. I would say this. If I look and it's obviously not a reflection, I know it's not an inverse. But to show it is an inverse, it seems to me you kind of want to do this, right? You want to show that f of g of x is x and g of f of x is x. And here I am with only a few minutes left, and you're like, well, why didn't you check for us? Well, here's why. I wanted to show you guys something. I wanted to show you that it's very important that you check both. And here's why. I'm going to take a very simple example. Take the function f of x equals x squared. Do you guys think you know an inverse? I think almost everybody here is going to say, well, what about this one? G of x is what? Yeah, radical. I'm going to write f negative 1 of x is square root of x, but I'm going to put a big question mark here. To see, are you guys right? How would I check? Well, what's the first thing I'm going to do, guys? What are we going to do? X. F of g of x would be, well, something squared. What is it we're going to square? Right? We said this is going to be called g of x. That's fine. F of g of x would be, well, what happens when you square the square root of x? What do you get? That's nice. And now we want to do g of f of x. And so what do? Well, you're going to take the square root of something, right? Because that's what g of x is. The square root of what? The square root of x squared equals, what's it equal? That's not fair. Let me give you an example. I've been writing x before, it seems like. Isn't the square root of x x? Here, let me try this, guys. Let's take negative 3 and square it, and then take the square root. What do we get? Well, what happens when you square negative 3? 9. And what's the square root of 9? Oh, we get 3. But what was x? X was negative 3. Well, let me say this. When I write this square root symbol, first of all, I'm going to be able to do it, because x squared is going to be positive. But when I write the square root symbol, it always spits out what kind of number? Does it ever spit out a negative number as the output? It always spits out what kind of output? Positive. So you know what I could say is the square root of x squared is actually this. The absolute value of x. Does that make any sense? Now I have a question. Is that the same as x? Well, sometimes it is, right? But not always. And you'll understand even more if you have a picture. So let's get the graphing calculator back out and finish up. Let's graph. Here we're going to graph y equals x squared. And we're also going to graph, do you guys know how to get this? Hey, actually, do you know how to get the square root function on your calculator? You actually do press inverse, or second here, depending what kind of calculator you have, second x squared. And then, so here I'm going to graph the square root of x. And also, what zoom did I say we should use? Number 5 is zoom square, okay? So I'm going to go ahead and graph it. Now, so far I've only graphed the parabola, y equals x squared. Now I'm going to start to graph, oh, here comes the square root function. That's not quite a parabola. See, the answer to this big question mark is no! Not an inverse. Not quite. Because if you took x squared and if you flipped it across the line y equals x, not only would you have this piece, but you would also have this piece. But that'd be bad because the pink and green is not a function. Are you with me? So, to get an inverse, you really need the domain must be from 0 to infinity to get an inverse. And we'll talk more about that tomorrow, guys. But you definitely have enough to do your homework, which is good. Have a good rest of the day.